So, good morning to all of you. This is your today's first lecture, Basic Electrical Engineering. So, up to last lecture, we have seen series circuit and parallel circuit. Let us continue with that point. Today, we'll see some analysis of series circuit and parallel circuit. So, before starting, we'll revise some important points of series and parallel circuit. So, all of you know that in case of series circuit, current remains same or the current has a single pathway. So current flowing through all elements remains same, whereas voltage divides. The total voltage in series circuit will be the voltage drop across all the elements connected in series. In case of parallel circuit, voltage remain constant and current splits. And the splitting of current depend upon the branch resistance. So these are the very important properties related to series and parallel circuit. So in series circuit, current remains same, voltage divides, whereas in case of parallel circuit, voltage remains same and current divide. So today we'll see apply the rules for analyzing series and parallel circuit. Now we'll compute the total resistance in series and parallel circuit. Analyze series parallel circuit for current through and the voltage across each component. Also, analyze the power dissipated by each element in a series parallel circuit and the total circuit power. So let us start with some topology. The first one is branch. So branch means a part of circuit that can be simplified into two terminals. In simple way, we can say a single element such as voltage source or a resistance can be considered as a branch. So in a figure, a particular resistance 3 ohm, 2 ohm, 5 ohm, there is a voltage source of 10 volt, a current source of 2 ampere. So these individual elements are called as the branch of the network. The next point, that is the node. A node is nothing but a point where two or more circuit elements are joined. So in electric circuit, we have to identify where the node are present, or we have to find out the spots or the location for a node. So we can identify nodes on any electrical network according to its definition. A node is a point where two or more circuit elements are joined. So you can see in figure at point A. So this point will be considered as a node. Why? Because at this point, the 5 ohm resistance and 10 volt source is connected. So the point A in a given network is called as node. Similarly, these 3 points are combinedly called as a single node B. Why? Because there is no any circuit elements are placed between the 2 points. We are having just a wire. So these 3 dot points are together called as a node. So we can see at node B, the 5 ohm resistance is connected. Similarly, 2 ohm resistance is connected, 3 ohm resistance is connected, and 2 ampere current source is connected. So this is the node A, node B, and at the bottom side, you can see between the two connection, there is no any circuit elements. So they are only a short circuited path. So we can consider, instead of considering 1, 2, 3, 4 point, we'll consider or will assign a single common point C, and that will be treated as a node of a given electric network. Clear? So this circuit can be simplified like this. So we are having three nodes A, where 5 ohm resistance and 10 volt source is connected, and at node B again 5 ohm resistance, 2 ohm resistance, 3 ohm resistance and 2 ampere current source is connected. And similarly we have considered a common point. So this is the node. So we can define node. Node is a point where two or more circuit elements are joined. And the meaning of circuit element is nothing but there may be a resistance, inductor, capacitor, battery, current source, voltage source. That they are called as the circuit elements. Is it okay? So now we'll see the analysis of a circuit. So there are two figures, figure A and figure B. First, you need to able to identify which elements are in series and which elements are in parallel. So we have already studied or we have already discussed the important points related to series circuit and parallel circuit. I'm revising it again. In series circuit, a current remains same, and in case of parallel circuit, the voltage remains same. So by observing figure A and B, कोण सांगू शकतो का तुमच्यामधून? So the basic is we have to identify which elements are connected in series and which elements are connected in parallel. So by observing figure A, the first of all, we can see that the resistance R2, R3 and R4, they are connected in parallel. So we have to simplify or we have to reduce the network by calculating their resultant resistances. So the resultant resistance for R2, R3, R4 will be what? It is simply the reciprocal of R1 plus reciprocal of R2 plus reciprocal of R4 will gives us the equivalent resistance for this combination. So after simplification, we'll have a single resistance between these two points, right? So we'll see its answer or the total resistance. So this is the formula to calculate the total resistance. We can say this resistance R2, R3 and R4 in a parallel. So we have considered over here R2, R3, R4 in parallel. Then R1 and R5, they are connected in series. So by adding these three resistances, R1 plus parallel combination of R2, R3, R4 plus R5 will give us the total resistance RT. So this is the simplified method to calculate the total resistance of a network between any two points. Okay. Now similarly, you can observe figure B. So here again we have to calculate the total resistance. Can anybody from your side?
Sir.
आवाज क्लियर येत नाहीये प्लीज. हॅलो
सर.
हा बोला.
1/, सर.
हा बोल ऐकतोय.
1/R1 plus 1/R3.
So by observing picture in figure B, we can say that resistance R3 and R4, they are connected in parallel. So first we have to solve these two resistances and we have to find out their equivalent resistance. Let us assume the equivalent value is R34, right? So how will you calculate R34? The value R34 will be equal to what? Is equal to 1 upon R3 plus 1 upon R4, right? Or in simple word, we can say there are two resistances in parallel. So just multiply these two resistances and add these two resistances. So we can simply say the R equivalent for these two resistance will be what? R3, R4 divided by R3 plus R4, right? So this will be your step number one. So the circuit will reduce to a single resistance over here. Then we can see that the R2 resistance will come in series with this equivalent combination. So that will be your next step. And after that, the equivalent resistance of this three resistance combination will come in parallel with resistance R1. So by solving this simple circuit, you will get the total resistance. Let us see the total resistance value for this. So this is very simple. Here you can say the first we have to solve R3, R4. So you can see here R3 parallel with R4. This is your first simplification. Then this combination will come in series with R2. That's why it is added plus R2. Then this combination of resistance and resistance R1, they are in parallel. So the RT will be equal to R1 parallel to in bracket R2 plus in bracket R3 parallel with R4. Is it clear to all of you? If you have any doubt, please reply, unmute, and I will see the rules for analysis. That is the first step or the first point is what? The same current occur through all series element. This point we have already discussed in our previous classes. In case of series circuit, the current remains same. So first point or the first rule is what? The same current occur through all series elements. The second point is the same voltage occur across all parallel elements. If n number of elements are connected in parallel, then the voltage across all the n element will be the same. So this is the property of parallel circuit. Point number 3 is KVL and KCL. We'll see this 2-point KVL and KCL after some days when we'll start with DC circuit, right? For all circuit, whether they are series parallel or series parallel, we have to redraw a complicated circuit showing the source at the left hand side. We have to label all nodes and solve the problem. So these are the reduction technique steps. So you can see on your screen the first point, series and parallel element from A must be combined to establish a reduced network of B. So you can see a series and parallel elements from figure A must be combined to establish a reduced circuit of B. So in figure A, R3 and R4 in series will add in and this combination will come in parallel with R2. So by solving this two or by solving this loop, you will get the equivalent resistance as RT dash in figure B. Then the series elements are combined to form a simplest of a configuration in figure C. Right. So from figure B, we can say that resistance R1 and RT dash, they are in series. Why? Because the same current flows through R1 and RT dash. So we can say R1 and RT dash in series. So by adding these two resistances, you will get the total resistance RT in figure C. Right. So once you get the value of RT, we can easily calculate the circuit current using Ohm's law. That is, current I is equal to V by R. So V, the value of V voltage is E volt, and the resistance of the circuit is RT. So we can easily calculate the circuit current. So these are the steps to analyze any electric network. So let us start with first problem. So here a series parallel circuit. So by observing a picture, so you can see that here the resistance R2 of 20 ohm, R3 30 ohm, and R4 8 ohm, they are in parallel. So this parallel combination is in series with resistance R1 and R5. So first of all, we have to solve the parallel combination of a given circuit. So we'll calculate R23 will be what? The equivalent resistance of these three parallel connected resistances. So we'll use this formula 1 upon R2 plus 1 upon R3 plus 1 upon R4. So by solving this, you will get a 4.8 ohm. Clear? Eh? So this is the value of three resistances connected in parallel. That is 4.8 ohm. Now this 4.8 ohm resistance will come in series with resistance R1 and R5. So this is the after calculation, after solving the parallel combination of R2, R3 and R4, you will get a new circuit model as shown in your screen. So you can see we have calculated the parallel combination value, that is 4.8 ohm. So now this 4.8 ohm resistance and R1 and R5. So by observing a figure, we can say the same current will be flow through the three elements. So we can say these three elements are in series. So the total resistance will be what? Simply the addition of R1 plus R23 plus R5. So thereby you will get 2 plus 4.8 plus 6, that will be equal to 12.8 ohm is the total resistance of a given circuit. Okay. So this is the next problem. Here again series parallel circuit below. How will you analyze the circuit? Right. So first we have to solve, or first we have to simplify this parallel combination. So how will you simplify this? So if there are two resistances in parallel, their total resistance will be what? Simply the multiplication of two resistances divided by addition of the two resistances. So RT dash will be what? R3 into R4 divided by R3 plus R4. That's this step will give us the RT dash for this parallel combination. So first we have to solve R3 and R4. So you can see on a screen that the resistance R3 and R4, they are in parallel, and the combination of these two resistances is in series with R2, and the entire combination is in parallel with R1. So these are the analysis steps to calculate the total resistance of a network. So let us see. First, we have to solve this parallel combination. The resistance, total resistance will be R34, and its value we can calculate using formula R3 into R4 divided by R3 plus R4. So it is 50 into 50 divided by 50 plus 50. So we'll get the 25 ohm resistance. Now we have to redraw the circuit, right? So we'll get our given circuit will be modified to this diagram where you can see resistance R2 and resistance R34 will come in series. So we have to combine resistance R34 and R2 for the total resistance R234, right? हे दोघांना ऍड केल्यावर किती येणार? This is 25 ohm resistance and this is 15 ohm resistance. These two resistances are in series. So we simply add the two resistances, then we'll get the total resistance R23 as R2 plus R23 and its value will be equal to 40, right? So once you calculate the total resistance, again we have to redraw the circuit. So this is the a modified circuit diagram where we have considered the resistance as R23 and we have calculated its value as a 40 ohm. So now you can see the resistance R1 and R23, they are in parallel. So we have to calculate the parallel resistance from element R1 and R23 for the resultant RT. So if there are two resistors in parallel, then its equivalent resistance RT will be given as 1 upon R1 plus 1 upon R23. So by solving this equation on your calculator, you will get the total resistance as 8 ohm. So now next question is to determine the RBC, resistance between terminal B and C for the given network. So it's again a very simple circuit where you can observe point B and C over here. So we have to calculate the resistance between terminal B and C. कसं solve करना B and C कडे? So by observing the image or a circuit, we can say that 100 ohm resistance and 50 ohm resistance. If there is a current, then same current will flow through 100 ohm resistance and 50 ohm resistance. So we know the property of series circuit. In a series circuit, current remains same. So we can say the 100 ohm resistance and 50 ohm resistance, they are in series. Clear? So this 100 ohm resistance and 50 ohm resistance, the same current will flow from 100 ohm and 50 ohm resistance. So we can say these two resistances are connected in series. So their total resistance is nothing but simply the addition of two resistances. So it will give us the 150. So we'll redraw a given circuit. So in figure B, you can see the modified circuit diagram. So here 150 ohm resistance will be replaced by 150 ohm resistance. So this is the modified circuit diagram. So in this diagram, again, after this modification, you can see that 150 ohm resistance and 50 ohm resistance, how they are connected. By observing a picture, we can say 150 ohm resistance and 50 ohm resistance, they are in parallel. So we have to solve a parallel combination of 50 ohm and 150 ohm resistance, right? So its answer will be what? We have to solve this parallel combination. So its equivalent value will be 1 upon 50 plus 1 upon 150. So after calculation, you will get a 37.5 ohm will be the equivalent resistance for this parallel combination. So once we simplify this parallel combination, then again we have to redraw a given circuit. So after modification, we'll have a new circuit like this, where you can see that a 37.5 ohm resistance come in series with 40 ohm resistance. So their total resistance will be what? It's simply the addition of 37.5 ohm resistance and 40 ohm resistance. So you'll get 77.5 ohm be the total resistance for this series connected resistances. So after this simplification, we again redraw our module. So the circuit will be reduced to this figure where 77.5 ohm resistance and 160 ohm resistance, they are coming parallel. So by solving the parallel combination using formula, you will get 52.2 ohm, and our circuit diagram will reduce to this model. So now you can see here that between terminal B and C, there are two resistances and they are connected in series. So by adding these two resistances, you will get the total resistance. So 20 plus 52.2 will give us this 72.2 ohm will be the total resistance of a given circuit. Clear? तर हे आपण जे डिस्कस केलं ते परत